We're going to now look at another method for finding probability, and this is the Venn diagram. So we did the tree diagram last time, and now we're going to look at a Venn diagram. With a Venn diagram, there's many different ways a Venn diagram looks. The more familiar way is we have two events, event A and event B. Sometimes they overlap, sometimes they don't, but our goal is to figure out probabilities, and we're going to put each of the probabilities in each of the different sections of our Venn diagram. Now, if we're looking at our first Venn diagram, what it tells us is that the events are disjoint. If events are disjoint, it's also called mutually exclusive, and what that means is that they don't overlap. So this Venn diagram is going to have a box, and we have two events, event A and event B. And this word disjoint means that there is nothing in between the two Venn diagrams. So what we have is we have Venn diagram A, we have Venn diagram B. The probability of A is 0.4, the probability of B is 0.5, and on the outside, what we have is 0.1. And the reason that it's 0.1 is because all probabilities have to add up to 1. So 0.4 plus 0.5 is 0.9. So what we need is 0.1 in order for it to equal to 1. That means all the possibilities. So our first problem says not A. If A is 0.4, then not A would be 0.6. Now what we have is A and B. That's where A and B overlap. There is no overlap, so that is impossible. There's nothing that's A and B. Now just to clarify, this right here means and. This right here means or. So when we're looking at A or B, it means that it could be probability A or it could be probability B. Since it's an or statement, either one means that our probability is 0.9. Now what we're going to do is we're going to look at another symbol. This straight line right here means given. That means that we know that this event happened. So given that not B happened, if not B happened, then that means there's not this possibility, there's only these two possibilities. So whenever we have a given probability, think of a fraction, we're going to put our denominator as our possibilities. Our possibilities are 0.5 because of the 0.4 and the 0.1. Remember, our given is not B, so that means B doesn't happen. Now, of these two choices, which one is A? A is the 0.4. Now, we can't have a decimal fraction. We could either have a fraction or a decimal. I'm going to treat it as a fraction, and I'm going to put 4/5, and that's my answer. Now, looking at example 2. With example 2, it doesn't tell us that it's disjoint. So we're going to go with a Venn diagram where we have A and where we have B. They tell us that it overlaps. A and B is 0.1, so we're going to put 0.1 in the middle. They tell us that A is 0.4. Now this is a little tricky. I'm not putting a 0.4 here, I'm putting a 0.3. The reason that I'm putting a 0.3 is because all of A is 0.4. Notice that A is around this whole thing, including the 0.1. So 0.3 plus 0.1 gives us our 0.4. In the same way, for the probability of B, I'm not putting a 0.5 here, I'm putting a 0.4 because 0.1 plus 0.4 gives me the 0.5. Notice that B is all of B, this whole circle. Now, on the outside, remember all the probabilities in our universal set, that's our whole box, have to add up to 1. 0.3 plus 0.1 plus 0.4 gives us 0.8, so our outside is 0.2. Now we're going to find our probabilities. This is not A and B. So it has to be not A. Not A would include this probability and this probability. And it has to be part of B. B is this probability and this probability. Whenever it's an and statement, it's where the two intersect. And they intersect at 0.4, so our answer is 0.4. Now what we're going to do is we're going to look at A or not B. So if we're looking at A or not B, first what we're going to do is we're going to look at A. So A would include these two right here. Not B would include this one right here is not B, this one right here is not B. Since it's an or statement, it could be everything. So it could be 0.1, 0.3, or 0.2, and that adds up to 0.6. The next two have our given. Notice that we have our little bar, our given. We want to remember that we're going to have fractions, and our denominator is whatever our given is. So our given is B. So B includes these two right here. That's our given, that whole circle B. So we're going to put 0.5 on the bottom. Now, of those two, which one is A? Well, this one is A because it's inside of A. So 0.1 goes on the top. And remember, we don't want decimal fractions, either a fraction or a decimal. So I'm going to write it as a fraction, 1/5. Now, looking at letter D, the given is A. So A is our denominator, which is 0.4. Now, we're looking at A. These are our two possibilities. Of these two possibilities, which one is B? B is the 0.1. So 0.1 goes on top. Remember, no decimal fractions. So I'm going to put 1/4. Now, looking at example 3, this time it tells us it's independent. Independent is going to look similar to a dependent event. We have A, we have B. The problem is they don't tell us the middle. And the reason that they don't tell us the middle is because with independent events, the middle is the product of the two. So 0.7 times 0.3 is 0.21. That right there is our middle. Now, if that's our middle, then that means that if A is 0.7, if we subtract 0.7 and 0.21, what we get is 0.49. And for B, it's 0.3. So if we subtract 0.3 and 0.21, we get 0.09. Now we're going to add up the 0.49 and the 0.21, which is 0.7. And 0.09 gives us 0.79. So that means on our outside is 0.21. So that's our Venn diagram. Now what we're going to do is we're going to look at not A, which not A includes these two probabilities, and B, which includes those two probabilities. Since it's an and statement is the similar as intersection. Where do the two intersect? They intersect at the 0.09. Now, if we're looking at letter B, this time we have an or statement. Or statement includes everything. So when we're including everything, that means we're including the A and the not B. Since or includes everything, we're including everything but the 0.09. So that would be 0.91. The next two have the given probability. Given probability, what I like to do is think of a fraction. Our denominator is our given part. That's what's going to go on the bottom. So what we have to do is figure out what our given part is, and that would be not B. So we're looking at everything that's not B. Not B would include the 0.49 and the 0.21. Those two are not B. So if we add those two up, what we get is 0.7. That's our denominator. Now, of those two, which one is A? A would be the 0.49. And that would be 49 over 70. Remember, with probabilities, you can reduce if you want, but you don't have to. Looking at letter D, our given part is B. B includes these two right here, which is 0.3. Now, of those two, which one is not A? Well, this one's not A. So we have 0.09 at the top. So once again, no decimal fractions. So 9 over 30, and you're welcome to reduce it.